Okay, let's look at a few examples here to elaborate on inverse trig functions and how they work with the original function. So in an equation, we use an inverse to undo an operation, right? So this first example, sine and sine inverse, they're inverses of each other. They would undo each other. So therefore the result is root 3 over 2 because sine inverse and sine cancel. I have this underlined with an X, though, and here's why. You have to be careful when we use inverse trig functions that X is actually in the domain. Okay, so for example, look at the second one. Sine of sine inverse of 2. Okay, if we think of the algebraic rule, right, sine and sine inverse, they cancel, and we should get 2. However, break this problem down. Order of operations says to do inside the parentheses first, so we need the sine inverse of 2. What angle would yield a sine of that angle equivalent to 2? Well, there is none, right? Because sine only ranges from -1 to 1. This is, in the parentheses here is the problem. We cannot do that. So this doesn't have a solution. That in fact is false. And therefore, we can cancel only when x is between -1 and 1. All right, same thing for cosine and cosine inverse. Tangent, though, different breed, right? Because tangent, remember, goes from -infinity to infinity. So the graph of sine and cosine both, are periodic, and they're a wave, right, from -1 to 1. But tangent does extend to infinity. Now what if we look at it in reverse? Sine inverse of sine of pi over 4. Okay, can we go ahead and just cancel these? Yes and no. Okay, we should always get a solution for these operations, but we can't necessarily cancel. This first one does in fact cancel, and the reason why is if we did order of operations inside the parentheses, sine of pi over 4 is root 2 over 2, and then the sine inverse, so what angle would create that, is in fact pi over 4. Okay. The problem with the second one, though, is, remember, this is our outer function, right? So we're doing sine inverse of something in here. So therefore, we have to be within the range of sine inverse. Remember that sine inverse only exists, so the range of sine, the domain of sine inverse, I should say. Remember that sine inverse only exists from -pi over 2 to pi over 2. So we cannot just cancel and say 3 pi over 4 because, right, we can't have that is not within the inverse function, the domain of that. So how can we answer this? Well, because sine of 3 pi over 4, which is in quadrant 2, right? Sine of 3 pi over 4 is in quadrant 2, and sine is positive in quadrant 2, I know that that is equivalent then to saying sine of pi over 4. So sine of pi over 4 has the same ratio as sine of 3 pi over 4. And now we're back to the problem right above. Right now I have this. So I'm allowed to do this because these two are equivalent here. And now sine inverse and sine cancel, and we do in fact get pi over 4. So be sure to pay attention to the domain of each. Make sure that if you do in fact use these canceling rules, that it in fact works. So all of these, again, for sine, in this order, sine inverse of sine, we have to make sure that our theta, that our x here, right, the angle, is between negative pi over 2 and pi over 2. Same thing with tangent. Okay, tan inverse and sine inverse are both with a negative pi over 2 to pi over 2. But cosine, if we're doing any inverse trig here with cosine, remember that's 0 to pi. Okay. All right, let's look at this next example here. We have sine inverse of cosine pi. And cosine pi, well, we have sine inverse and cosine. They're not inverses of each other, right? Same here, sine inverse and cosine. So we can't just cancel. Sine inverse and sine would cancel if it's, all within the restrictions, but here this doesn't cancel. So let's look in parentheses. Cosine of pi is -1. And now we do sine inverse of -1. So remember, cosine has to do with the x on the unit circle. So here we're over at pi. Cosine, right, we're at -1, 0. Cosine is the x, and that's why cosine of pi is -1. Now I'm asking, what angle yields a sine of -1? Well, sine is y, right? So this point here, 0, -1, has y as -1. Now it is 3 pi over 2, but like we were saying back here, sine inverse is only in quadrant 1 and 4, but we have to deal with a negative angle. So this is negative pi over 2 because of the range, right, of the inverse. Okay, let's look at this last example. Sine inverse a cosine of negative pi over 2. Okay, cosine of negative pi over 2. So we were just on that angle up here, right? Negative pi over 2. Cosine is x, so this is 0. And now we have to look which angle would give us a sine of 0. And sine is, again, y. So now we're back here at 0 radians, right? Or 0 degrees are the same, but we always want radians. So 0.